Hi everyone, welcome back to the Workplace and Apprenticeship 20 videos. In this video, we're going to look at lesson 1 from chapter 3, which is talking about surface area of prisms. So just to do a quick recap, the surface area is the sum of the area of an object's faces. And in order to calculate the surface area, it's probably in your best interest to draw its net, that way you can clearly see its faces. So a net is a pattern that you can cut out and fold to make a model of a shape. So in this example here, we have a pizza box, and say if we want to go from the original shape to its net, you just have to imagine basically unfolding that box. So you usually typically start with, say, maybe your base, which is maybe right here, and then you would just imagine unfolding that pizza box. So typically what you would do is you'd first open up that lid, and then you would lie it flat, and then you might pull apart these sides here, okay? So this is going to take, in order to draw the net, it's going to take some imagination and some creativity, but trust me when I say a net will definitely help you out in terms of calculating your surface area. So let's try an example of drawing the net and then calculating the surface area. This one here is example number 1 from your notes. So Nicholas ships posters and reproduction art prints to customers in shipping boxes made in the shape of an equilateral triangular prism as shown in the diagram. So what we're going to do first here is draw a net of the box and label the dimensions of each of the side. So here we have what's called a triangular prism, and what we need to do is draw the net and then label its dimensions. So some things that we know here about this shape here is that it's an equilateral triangle. So that means that each side or each of these corners of this triangle are equal in length. So your left side, your right side, and the bottom there will be 15.2 centimeters. So whenever I'm trying to draw the nets, I try and relate it to something that I know that has a similar shape. So in terms of, say, this triangular prism, I might think of, say, a Toblerone. So when I'm trying to get into that package of that Toblerone to get some of that delicious chocolate, you might first start by opening up or laying down that triangular face there. So I always start with the base. So here's my box, or the bottom of my Toblerone. And then what I do is I fold down this little front face here that's closing in that chocolate. So I'll fold that down first, and usually I'm able to pull out the chocolate from there. But then say I want to expose all the chocolate without, tipping it over and sliding all that chocolate out. So maybe what I'll do is I'll pull maybe our right face here of our Toblerone package. I'll pull that one down. So I'm going to pull that one down. So it's going to be maybe off to the side here. And then I'm going to pull the next side down, so your left side. So it'll be on the opposite side of your base there. And then we should still have the back of that packaging. So that one there will be similar to the front. So when you lay that down, it should also be a triangle. And this here is essentially it to draw on your net. And now all that we have to do is label the dimensions of each of those sides. So from our diagram here, we know that the length of this prism is 96.5 centimeters. So that's this long part right here. So that's 96.5 centimeters. And that's going to be for each of these little sides here. So going from your base here is 96.5 on the right side, the left side would be 96.5, and same with your left little part there of the triangle, that'll also be 96.5 centimeters. Then we can also draw or label our triangles. So you know that each of these sides here is 15.2 centimeters. And we know that because this part here, so the length of our rectangle here would touch this side of the triangle, we know that it has the same length. So this here, this side, has 15.2 centimeters as well. We can label the same here for each of these triangles and the widths of those rectangles as well. So 15.2 centimeters for your width of that rectangle, and then the length of your triangle, and same with on that left side over there as well. So if you were to imagine folding those up, you know that this part here of your triangle is the same as that width of that rectangle, okay? And then from there, we've drawn the net, we've labeled dimensions. So let's move on to our next example. So in part B of this question, we need to calculate the surface area of the box. So in order to calculate the surface area of the box, this is where our net is going to come in handy. So let's go back up to that net. And what we need to do is we need to calculate the area of each of those faces. So we need of our two triangles, so I'll label that number 1 and number 2. We need to calculate the area of each of those rectangles as well, which is, I'll label it 3, 4, and 5. So in total, we're going to have to add up 5 numbers. One thing that's really nice, so that since this is an equilateral triangle, we really only have 3 calculations in total. We know that these two triangles will be the exact same size, which means that they'll have the same area, and same with these rectangles. They all have the same width and they all have the same length, which means that rectangles labeled 3, 4, and 5 will all be the same. So then that third calculation that we have to do is just adding everything up. Okay? So let's find the area of our first triangle here. So let's find the area of the triangle. So in order to calculate the area of a triangle, you need the following formula. So area is equal to 1/2 times your base times your height. So say in a triangle, your base is the bottom length here, and then your height is going from the top of that triangle going down to that base. So that there is your height. So let's go back up to our diagram and see if we can find that base and that height. So looking at our diagram here, we know that the base of our triangle is 15.2 centimeters, but one thing that we didn't label here was the height. One thing that's really awesome is that we were given the height of the triangle here in this diagram. So we know that the height here is 13.2 centimeters. So let's plug that into our formula. So we have area is equal to 1/2 times your base, which was 15.2, times your height, which was 13.2. You can plug that into your calculator, and what we should find is that our area is equal to 100.32, and make sure you include your units here, so it's centimeters, and every time we do area or surface area, our units are squared. So this here is the area of each of those triangles. Now what we need to do is, our second step here is to find the area of the rectangles. So in order to find the area of each of those rectangles, you need to use the following formula. So area is equal to length times your width. So let's go back up to our diagram and see if we can find the length and width of that rectangle. So looking here, we can use, say, rectangle number 5. This here is labeled quite nicely. So we know that the width of that rectangle is 15.2 centimeters, and then the length of that rectangle is 96.5 centimeters. So let's plug that into our formula. So our area is equal to your length, which was 96.5, times your width, which was 15.2. If you plug that into your calculators, you guys should find that your rectangle is, the area of that rectangle is 1,466.8 centimeters squared. And now that we have the area of each of those different shapes, now what we can do is we can find the total surface area, which is, remember, if you remember the definition, is the sum of the area of the faces. So you have to add up the area of each side. So step number 3 here is find the surface area. And I'm going to shorthand this as SA. So your surface area, so that's equal to the area of your shape number 1, plus your second shape, plus your third shape, plus fourth, and your fifth shape. So looking at, say if you were to go back and look at your net, your first and second shape were those two triangles, and then third, fourth, and fifth are those rectangles. So you're going to take the area of your triangle, which was 100.32. Then your second shape was that triangle as well, so add it again. And then add it with your area of your rectangle, which was 1,466.8. And shapes 4 and 5 were those exact same rectangles, so just add it again twice. If you were to put all of that into your calculator, what we should find is that total surface area is equal to 4,601.04 centimeters squared. So don't forget those units. And now that we're all done all of our calculations, just don't forget this here was a word problem, so we need to answer this with a sentence. So we could say the surface area of each shipping box is 4,601.04 centimeters squared. And with that, we're all done the example. And so if you guys have any questions about drawing nets or calculating surface areas, just make sure to come see me in class or text me on Remind 101. So thank you guys so much for watching.